screen?
Yes,
Yes,
ma'am.
ma'am.
Just a minute. Okay. So outline on farm power and machinery engineering syllabus. So in our syllabus, we'll be studying various aspects. First, about the tools, various workshop tools, various carpentry tools, and farm machinery. So do you have any idea about farm machinery? Can someone say about what we are going to study? At least any idea what it might be?
Implements and tractor.
Yeah, correct. So, before going to those implements and all, it will come under machinery part. So, first we'll proceed with the tools. What are the various tools that we'll be using? And the tools also, carpentry tools will be there, smithy tools are there, smith work, welding, casting, then machinery, as you rightly told, that it is about tillage operations like moldboard plow, disc plow. I'll show you all the images and all. So we'll be studying some portion about the farm machinery, and then we'll have the other half. This machinery tools will be half of our syllabus. The rest half will be about the renewable energy sources. Do anyone have idea about renewable energy source?
Yes, ma'am.
Okay, so we'll study about renewable energy sources like solar energy, wind energy, then biomass energy. So all that we'll be studying in this particular farm power and machinery engineering course. So tools in the sense carpentry first we'll start. It is a technological process for making various wooden components like the components which we use in our building work, then furniture, toys manufacturing and all. So here you can see some of the carpentry tools like steel ruler. So this particular ruler, what you are seeing here, steel ruler, then steel tape, then marking gauge, tri-square. So likewise, so all this hammer, anvil and all, it comes under smithy work. Smithy work in the sense, we heat a particular metal, okay, and then to bring it to sufficient plasticity, then we go with followed by hammering, because in order to mold that piece of metal into a desired shape, so that work we call it as smithy work. Then welding also we'll study in this syllabus. Welding means what? It's a method used to combine various metals or materials, we can say. Then casting process. Casting process in the sense where we use a particular mold. A mold will be there, so which is having a desired shape. And in that mold, we'll pour some hot molten liquid so that that liquid will convert into a suitable shape. That is what casting is. So this together it is said to be a workshop technology, and we'll be studying various workshop tools in our syllabus. So this is casting and welding. As I was telling you, the casting, that means we'll pour this particular hot molten liquid into a desired shape so that we get a desired shape out of that. And welding, as we all know, and this is too we will be studying in detail in our syllabus. So then mechanization, as you are seeing lot of implements here. First I want to ask, what is the difference between a tool and an implement? Can anyone say? Tool is nothing but an individual working element. Okay, so implement which doesn't have any driven power, it will be attached to some tractors. So it is an essential input. So all these machines, what we are seeing, so they are very much used in our field operations, mainly for increasing the production as well as productivity. What is the difference between production and productivity? Production, we speak in terms of tons. Productivity, we speak in terms of area, like tons that is produced per hectare. So if you talk with respect to area, we call it as productivity. So field, if you take farm, if you take, there are various number of operations, right from tillage till harvesting. A crop, if you want to lay, there are n number of unit operations. So tillage means what? Any idea about tillage? Tillage means it is breaking or loosening the soil mass, hardcore soil mass, so that in order to provide some favorable conditions for the plant to grow. So that particular operation we said tillage, the very first operation which we carry out in a farm to raise the crop, that is said to be tillage operation. Then planting, plant protection equipments are there, harvesting equipments are there. So we might be seeing lot of harvesters. So combine harvesters we say. So harvesting, then threshing machinery, all this machinery part also we will study in our syllabus. So this is the first one I was talking about, the moldboard plow. So where we break the soil, it is nothing but a mechanical manipulation. This is a first primary tillage unit actually. So what it will do, it provides favorable conditions for the crop production. So it consists of breaking the compact surface of the earth. So what it will do, it is being hitched to a tractor, and as it is moving forward, it breaks the soil and it will lose the soil mass. So that hard soil will become loose, so that it provides proper aeration for the crop to grow. So that is moldboard plow. And the second one, what you are seeing, it is nothing but the disc plow. It also comes under a tillage implement only, but it is used mostly in the hard rock areas or stone areas where we'll have certain hard lumps. So there we prefer this disc plow. The third one, it is cultivator. So cultivator also, it is used first to remove the weeds, and also it will loosen the soil mass. This is cultivator. Then the fourth one, it is rotavator. Rotavator, what it will do? It will pulverize the soil. So once after plowing, we will have big clods. So that big clods will be refined, or it will broken down into small soil particles that can be done by means of rotavator. Then here you can see seed drill. So where it will make certain rows, and where it will drop the seeds, and followed by covering of the soil also, seed drill. Then you can see rice transplanter. So where we can lay the seedlings, like where we can grow the seedlings at certain place, and we can transport them, and we can transplant them into the soil. So that is mechanical rice transplanter. And these usually we will be observing in our fields, that is combine harvesters meant for harvesting of the crop. So likewise, n number of machineries are there. We will study in depth in this in our farm power and machinery engineering course. So next comes the renewable energy. So this is the first half, like tools, then machinery. Then the rest, it is about renewable energy sources. So what are renewable energy sources? So these are the sources that are present in the nature, and they can be renewed again and again. That means this particular sources will not get exhausted though we are using. So such energy sources are said to be renewable energy sources. That means you can use this energy again and again. So that is renewable energy source. So many energy sources are there. Biomass energy, which is coming out from the biogas plants. So in our syllabus, we will be studying majorly about 3 biogas plants. Okay, so what is the raw material we use? How the biogas will be produced? So that we will study. Then gasifiers. So out of biogas plants, we get biogas. Then out of gasifiers, we get producer gas. So producer gas, it is the one which is used as a fuel for the internal combustion engines. Okay. Then solar energy. So the energy that is coming from directly from the sun, we call it as solar energy. So the plants, they use this particular energy in for doing this photosynthesis process, and energy will be liberated. And wind energy, hydropower, the hydropower, that means the energy that is getting obtained from the dams and all. So where the kinetic energy of the water is getting converted into some electrical power, that is hydropower. Then tidal power. Tidal power means the energy that is obtained from the tides of the sea. So that is tidal power. Then geothermal energy. So this particular one, it is geothermal energy. What is geothermal energy? The energy that is present in the deeper layers of the earth crust, that is said to be geothermal energy. So all these energy sources we'll study, but most importantly, we will focus on only three main energy sources, that is solar energy, wind energy, and biomass energy. So these are the biogas plants, mostly we'll be seeing in the villages and all. So this is the line diagram of the biogas plant you can see here. So this is the line diagram where this is the tank, will dump all the waste material, that means cattle dung along with some water. We call it as a slurry. The dung that is obtained from cattle, cows, buffaloes, sheep, whatever it is. So that dung we use, will mix it with some water in this tank. We call this as an inlet tank. Then we'll dump here and that will move to this place. This complete compartment is said to be digester. So digester. Are you able to see my screen?
Yes, ma'am.
Yes.
Yeah. So we'll dump all the raw material in this inlet tank, and from there the material will be going into the digester where the material will get, where the slurry will get digested. So digested, it takes a period of time. Digestion means what? The particular slurry will be acted upon by some microorganisms, which results in the formation of a gas. So that we call it as biogas, and that biogas will be collected at this point. We call this as a gas holder, okay, which will collect the biogas. What for this biogas is used then? So this biogas, it can be used for a number of purposes. We can use this biogas for cooking purpose. We can use this biogas for lighting purpose. Okay, we can use this biogas for heating and all, electricity generation. So likewise, a number of uses are there with this biogas. And whatever the leftover portion after digestion, how much time it take? Now the question comes. Okay, the material we have sent and it goes into the digester, and how much time it takes to digest that material and produce the gas? It takes a time of 30 days to 45 days. So that time we call it as retention period. You can note down retention period. So from there it will be going into the outlet tank. So whatever the sludge or the used slurry after digestion, whatever the leftover portion, that will be going into this outlet tank. Gas will be collected here. The material, the waste material after digestion will be collected at this particular point. And now what we will do with this material? This material we can use directly as a manure to our crops. So this is in short about the biogas plant, but we will study in detail as we proceed with the course. Then solar energy appliances also we'll be studying here. So this is the first one, flat plate collector, which we usually observe on the rooftop of our buildings and all. So this is said to be flat plate collector, which is used for heating of water by using the solar energy. So here you can see some lines. So these are nothing but the pipes in which water flows. And below that there is one black surface. So this is used to absorb most of the solar energy. So black absorbs the solar radiation and further it raises the temperatures of hot water, and that hot water, as the temperature of the water increases, the density will be less and it goes to the tank, and completely here in this tank initially it will be cool water. Over a period of time, all the water that is present in the tank will become hot and finally we'll get the hot water. So this is flat plate collector. Then paraboloid concentrating collectors we will study. So this is a concentrating collector. Concentrate means what? This particular chamber, whatever you are observing, this is a disc actually. So this will concentrate the solar radiations at a single point, and there the temperatures will be more than 100, 200 degrees Celsius. So that heat energy will be using for our applications. Next, cylindrical parabolic concentrating collectors are there. So this is paraboloid, this is parabolic, cylindrical parabolic. And the speciality with this concentrating collector is it concentrates the radiations so that the temperatures will be more than 100, but it will track the radiations as per the direction of the sun. So that means it will be moving as per the direction of the sun. So it captures maximum amount of radiation. So that also we'll be studying. Then by using solar energy, we can dry our agricultural produce. So what is meant by drying?
Sagarika. Sagar. ಬಂದ ನೀನು ಏನ ಫಂಕ್ಷನ್ ಇರ್ಲಿ ಏನಿರ್ಲಿ ಬೇ ಒಂದ್ ಇದ್ದೇ ಇರ್ತಾನವ ಬಿಟ್ಟೋಗ್ಯಾರ ಅಂದ್ರ ಬಂದೆ ನೀನು ಸಸ್ಪೆಂಡ್ ಮಾಡಿದ್ರ ಅನ್ಸುತ್ತೆ ಲೈಕ್ ಬೇರೆ ಕಡೆ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಿ ಇಷ್ಟು ತಿಂಗಳು ಅಂತ ಹಾಕೈತೆ ಇಷ್ಟು ತಿಂಗಳು ಅಂತ ಬೇರೆ ಕಡೆ ಮಾತ್ರ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡ್ಯಾರ.
Hello. Hello. Yeah, am I audible?
Yes, ma'am.
So someone called me in between. Shall I proceed or?
Yes, ma'am.
Okay. So solar energy is mostly used for drying of the agricultural produce. So we dry the material. Do you know what is meant by drying?
Dehydration.
No,
Remove the
drying is
moisture.
different from dehydration, ma.
Remove the moisture of the product, ma'am.
Okay. That's it. Correct. What you told is correct. Drying is removal of moisture to a certain limit. Certain limit in the sense, you take a fruit, it will have a moisture of around 50 to 60% moisture, let us say. So high moisture food if you take. So if we are reducing its temperature to 15% or 20% to a desirable limit, we call that process as drying. And someone said dehydration. So dehydration means what? Complete removal of moisture. That means we remove the moisture completely to a bone dry level. So that is said to be dehydration. So solar energy is used for drying of agricultural produce, and we will study about lot of grain dryers. And the last one we will study in this, it is wind energy. So where the we use lot of windmills. We'll study about windmills, the components of windmill. So how that wind energy is converted into suitable energy forms, especially the electricity. So types of windmills we'll study: horizontal axis, vertical axis, and in that horizontal axis and vertical axis, again, it is divided into many types, Savonius, then Darius types. So each windmill has its own speciality, its own advantages and limitations. All these things we will study in detail. So this is about the complete outline of our syllabus, Farm, Power and Machinery Engineering. Is that clear?
Yes, ma'am.
Okay. So now we'll proceed with our lecture number 1. Okay. Are you able to see the screen? So
Yes,
first,
ma'am.
it is about
Yes,
concept
ma'am.
and limitation of renewable energy sources. So we'll take up that tools and machinery part separately. So first we'll proceed with the renewable energy source. So what is the criteria for assessing the potential of renewable energy source? What is renewable energy source? We'll study what are its limitations. That means what are its drawbacks. We'll study and criteria for assessing the potential. So in our country, what is the potential to produce this particular energy? And classification of renewable energy sources we'll see. As I have already shown you in a PPT, renewable energy sources are solar, wind, hydro, geothermal, biomass, ocean energy. So many energy sources are there. So we'll classify them and comparison between the renewable energy sources and non-renewable energy sources. So this is what we are going to study in lecture number 1. So first, before that, we'll study what is energy. So what is energy? Energy is nothing but capacity to do work or capability to produce an effort. So that is said to be energy. So that means if you want to perform some work or if you want to do something, we call it as energy. So units of energy, you can note down very important point here. So the units of energy is expressed in terms of Newton meters or joules. So that is said to be unit of energy. And there is one more unit, energy density. What is meant by energy density? So that is joules per kg. So energy, it is very much important in our day-to-day life. And the civilization, degree of civilization is also spoken in terms of energy only. So how far we are utilizing the energy effectively. Okay. So before the industrial revolution and all, we mostly depend on only two sources, human source, animal power. So where we don't have much machinery at that time, we are dependent mostly on that human and animal sources, and mostly wind and water energy also. And suppose for cooking at that time, we used firewood. So firewood means the sticks and all what we used for cooking purpose. Okay. So the energy that is coming out from the firewood is the main source of heat and light for us. So that is the main source for cooking purposes. So then now we'll see some of the statistics. The total energy production in India, you can note down, it is the latest one, it is 14,858 into 10 to the power 15 joules. So now if you take this particular energy production in India, so consider it as 100%. In that, 93% of the energy, it is coming out from the fossil fuels. Now, what are fossil fuels? It is nothing but the coal, oil, natural gas, all these things are said to be the fossil fuels or commercial energy sources, we can say. Okay. So now out of this 93% is coming out from the coal. Coal means coal, it is contributing 56. Then oil and natural gas is giving 37%. Then water and nuclear power is contributing 7%. So 56 plus 37 plus 7. So altogether it is 100%. That means out of this what we come to know, it is most of our energy requirement we are taking from the fossil fuels. So now there is a scope for the renewable energy sources to replace this one. So now this much is the energy production in India. Now we compare it with the world. So when we compare our energy production with the world, it is only 3.5% of the total world production. So there are various forms of energy, different forms of energy are there. First one, it is heat energy. The second one is work. What is meant by work? Can anyone say what is meant by work? It is nothing but we transfer the energy. Work means what? We transfer the energy with the help of some force covering a particular distance. That's why I said units of energy is what? Units of energy, it is Newton meter. Okay, so this is the unit of force. So this is the unit of distance. So the force covering a particular distance in a particular direction, we call it as work that has been performed. Okay, so transferring the amount of energy with the help of a force covering a particular distance in a direction, in a particular direction is said to be the work. So energy is nothing but again the force that works at a certain distance, we call it as energy. So there are many energy forms you can see here. Electrical energy, you can note down also. There are many energy forms. Electrical energy, mechanical energy, chemical energy, heat energy, solar energy, and nuclear energy. So mechanical energy means the energy that is possessed by an object due to its motion. So due to its position or due to its motion, we call it as mechanical energy. And chemical energy, okay, heat energy, then solar energy, the energy obtained by the sun, and then nuclear energy. So it is a form of energy which is released from the nucleus, that means our protons and neutrons. So that is said to be nuclear energy. Among all these energy sources, the most important one or the most convenient form of energy, we can say it is the electrical energy, because it can be easily transported, easily controlled, and we can convert this particular energy into various other forms of energy with 100% efficiency. So that is the main advantage with this electrical energy. So, but the only limitation with this electrical energy is that it cannot be stored in large quantities. So that is the limitation with this electrical energy. So we are talking about the various energy forms. We have seen what is energy, units of energy density, and various forms of energy we are seeing. So I was talking about the electrical energy. It can be easily transported, controlled, and converted into other forms with 100% efficiency. The only limitation is that it cannot be stored in large quantities. So you can take down this particular flow chart, sources of energy. So we have conventional sources, we have non-conventional sources. And non-conventional sources are nothing but our renewable energy sources. Please don't get confused here. So in our exam paper, this renewable energy can be called as non-conventional energy sources also. So don't get confused with the non-conventional energy sources. So conventional or non-renewable, renewable and non-conventional sources. So that is the what to say nomenclature we have to use. So conventional sources are divided into two. Okay. So it is first one coal, petrol, electricity. And this firewood, this comes under non-commercial. It is firewood, mostly used for cooking of food. Then straw, that means after harvesting, whatever the leftover portions that we call it as a straw, and dried dung. Okay, so all these things we call it as conventional energy sources. So non-conventional energy sources are otherwise known as renewable. So these are said to be the renewable energy sources. So conventional, or we can call them as non-renewable. Okay. So this bioenergy, solar, wind, tidal, and energy from the biomass, all these things together we call it as the energy that is getting developed or generated from all these are said to be the non-conventional energy sources. So these are some of the images showing you what are commercial sources. So commercial sources, that is coal, petroleum, electricity, firewood, straw, dried dung, many others. So I have just quoted some few which are very important. And so these are the commercial energy sources. That is the fuel, and then coal, then electricity. Non-conventional, or we can call them as renewable also. So the examples are solar. So solar energy, we mostly use solar PV panels. Do you have any idea about PV panels? Have you seen this particular PV panels anywhere?
Yes, ma'am.
Solar panels. Okay. So what is the material with which it is made of? Any idea? So they are semiconductor materials which is made out of silicon. Okay, so that we'll study in depth in our syllabus. So solar energy, then hydropower. So hydropower, that means the energy that is generated by using the water at a higher elevation. That means they will be falling onto the turbines. Further, it will leads to the generation of electricity. Then wind energy by using the windmills. Tidal energy by means of the tides. So how tides are created? By means of, you can note down, by means of Earth's gravitational force. So waves are different, tides are different. So waves are created by means of the wind's interaction with the surface. Suppose ocean waves we say. So wind that is getting interacted with the surface of ocean and it results in the formation of waves. Whereas tides are created as a result of the Earth's gravitational pull. Then geothermal energy, so you can see in the deeper layers of the earth. So the hot molten liquid, whatever it is present, so that heat or that temperatures can be extracted and that can be used as a source of energy. So that is geothermal energy. Then biomass, I have already shown you a biogas plant. So how the biomass will be disintegrated or digested and biogas will be generated. So these are all the non-conventional energy sources. So these are the various biogas plants. And these are the gasifiers. So gasifiers, what it will produce? It will generate producer gas. Biogas plants will generate biogas. Gasifiers will produce producer gas. Now, classification of energy sources, you can take down this. I'll be providing you the material for this. I'll be sharing to Rida madam, or she'll be sharing it to you. Classification of renewable energy sources, commercial primary energy sources and renewable energy sources. So these definitions are very important. So commercial energy sources, by this time you might be having some idea. That means these are nothing but the non-renewable energy sources. So they are present in nature for a very long period of time and they cannot be replaced if exhausted. They are said to be the non-renewable energy sources. So the definition for commercial energy source is that these are the nature gifted sources. And if we utilize them or if they are consumed, it cannot be replaced. So those are said to be the commercial primary energy sources. Examples of commercial primary energy sources are coal, petrol, natural gas, thermal power, hydropower, nuclear power. So all these things comes under conventional sources or commercial sources or non-renewable energy sources. The next definition is for renewable energy sources. So renewable energy sources means these energy sources are continuously and freely produced in the nature and they are not exhaustible. So they are said to be the renewable energy sources. So examples are solar energy, biomass and wood energy, geothermal energy, wind energy, tidal energy and ocean energy. So you can take down the advantages of renewable energy sources. So these, the word itself says it is a renewable energy. So these energy sources are renewable. That means there is no danger of depletion. So these are present in nature and they are inexhaustible. So that is the main advantage with this renewable energy source. Then the power plants that are running based on this renewable energy sources, they don't have any fuel cost. So why it doesn't have any fuel cost? Because solar energy, so it is coming directly from the sun. So we need not spend much money on the raw material here. So even the wind, even for the biomass means all the waste we will be collecting. Okay. So the raw material cost is negligible here. So the running cost of this particular power plants is also very less. And they are more site specific and are used for local processing and application. So site specific in the sense, so wherever we want, suppose we just have to take some minimum, what to say, caution for construction of this plant because sunlight is available everywhere. So you need not transport this from some other place. So there is no need for a transmission and distribution of power. So they are more site specific and they are used for local processing and local applications. And they have low energy density. So no pollution will be there, no ecological balance problems also. So that is also one of the advantage. Then most of the devices, they are simple in design and they are made out of local materials and they can be constructed by local skills or by local people. Suppose biogas plants, if you have seen, it's a simple construction which is made out of bricks and cement and all. Okay. So it doesn't require much, what to say, high skilled technicians and all. Okay, so the use of renewable energy, it can help to save foreign exchange and it generates local employment. So that is the basic advantage of this renewable energy sources. Then the rural areas and remote villages, they can be better served with this locally available renewable sources of energy. So they are talking about this biomass energy. So where this biomass will be produced? Biomass, it is mostly obtained from the biomass sources are, you can note down what are biomass sources. That is, the first one is agricultural residue. Agricultural residue means what? After harvesting, whatever harvesting of the crop, whatever the leftover portion, we call them as agricultural residues. And that can be used as a source, that can be used, call it as a biomass. Then cattle dung or animal waste or animal residues. So those are also said to be the biomass sources. Then municipal waste, then sewage waste, household waste like our kitchen waste will be there. So that also said to be the biomass source. So all these things, the rural areas and remote villages, they can very well be constructing this. It's very easy for them to construct the biogas plants and to grab the raw material and to produce the biogas, and they can use this particular energy very effectively. So there will be huge savings for transporting the fuels or transmitting electricity from long distances. So it is available in rural areas. So it's better to construct the biogas plant in the rural areas itself. So a lot of transportation cost will be saved here. So that is also one of the advantage of renewable energy source. Now, for every source, it will have its own limitations. So low energy density, in the sense it needs large size of plant. So no one asked me a question about energy density. So first tell me, what is the density?
Mass per unit volume.
Correct, mass by volume. So low density in the sense volume is more. If you take plant material, it will have huge volume. Okay, so if you want to dump all the plant mass, plant material and all, you need to construct a large size of biogas plant. So it leads to increased cost because the construction cost, it's not like simple small biogas plants are not sufficient to dump a huge volume of material. So that's why we are telling the density of the material, it is less. That means the volume will be more for this particular raw material. So it results in an increased cost of delivered energy also, because the construction cost will be higher. So the delivery cost is also will be high. Then intermittency and lack of dependability. So you cannot totally depend on this particular renewable energy sources. Let us say the best example, it is solar energy. So you cannot depend totally, that energy will not be available 24 by 7. Only during the daytime, only at particular timings you can grab maximum amount of solar radiations. So and in rainy days and then some winter season and all, you cannot get sunlight, proper quantity of sunlight. So we cannot totally depend on this particular renewable energy sources. That is one of the limitation. So low energy density, it results in low operating temperatures and hence the efficiencies are also less. So although these energy sources are free, there is definite cost effectiveness associated with its conversion and utilization. So raw material is available free of cost, okay, fine. But it needs proper conversion technologies. So it needs proper technology to utilize them properly. So that's why definite cost will be there for this particular renewable energy sources. And much of the construction materials are themselves very energy intensive. That means apart from this biogas plants, if you take the solar panels, so it require a lot of cost. That means the material itself, the design itself is very complicated to manufacture that particular solar cell. Okay. The low efficiency can result in large heat rejection. Sometimes it leads to thermal pollution. And also the renewable energy source, it uses large land masses. You might be seeing a lot of panels, solar panels. So everything is being arranged. Okay, so it requires to install this many panels, it requires a large amount of land. So these are some of the limitations of renewable energy. So far we have seen about what is energy, what are its units, then what are commercial energy sources, what are renewable energy sources, advantages and disadvantages of renewable energy sources. And there are some new sources of energy also. So like tidal energy, ocean waves, geothermal energy, animal power, agricultural, the energy that is coming out from the agricultural residues, nothing but the biomass energy. So certain new energy sources also mentioned. And now in our lecture, we have to talk about what is the criteria for assessing the potential of renewable energy sources. So what is the potential? So I hope you are seeing this PDF. This particular PDF I'll be sharing to madam. So here you can see the potential of this particular renewable energy source. Solar energy, if you can see, it is a major power source and its potential is almost 1.178 billion megawatts. So also which is about 20,000 times the world's demand. But so far it could not be developed on a large scale. So it can be utilized as a thermal power or photovoltaic. Photovoltaic effect I'll be telling you. That means photovoltaic effect is nothing but the solar energy, the sunlight is getting converted into electricity. We call it as a photovoltaic effect. Okay. So the potential for us, it is 170 out of the total solar energy that is available for us, we can generate 178 billion megawatts of energy if we can utilize all the solar energy effectively. But we don't have proper conversion technologies or proper source to utilize all these solar energy. Then if you take wind energy, its potential is that like in California or so, they started generating this particular wind energy. So 500 megawatts of energy is getting liberated from 900 wind turbines and all. So for us, if you want to install this windmills and all, we need certain places like winds at a wind speed of more than 3 meters per second, air with a velocity of more than 3 meters per second is only considered to generate energy. So sometimes it is more than 10 meters per second also. So effective winds we say. So that particular winds only be utilized for generation of energy. Okay. So for us, where we can install this particular windmills, we can install them mostly on the coastal areas, hilly areas and valleys. So for us, mostly on the coastal line of Gujarat, Maharashtra and Tamil Nadu, there we have windmills. And potential in India, it is estimated between 20,000 and 25,000 megawatts of wind energy can be generated. So now energy from seas. See if you can say take the wave energy, tidal or ocean energy. So about 13 kilowatt per meter height of wave can be generated. How much energy can be generated per 1 meter height of a wave? So if you can convert that energy, we can get almost 13 kilowatts of energy can be generated. So you can go through this particular PDF. Similarly, the biomass also. So the potential for agricultural residues. So if you collect all the waste, so all the agricultural residues, it is estimated to be 480 metric tons, out of which we are getting 100 metric tons from our food grains only. That means the waste, after harvesting, whatever the leftover residues, if you collect, it is almost 100 metric tons, and we can maximum grab this much amount of plant material and we can generate energy out of this. So you can just go through this particular PDF where they told what is the potential. Potential is nothing but how much energy can be generated. What is the possibility of generation of energy? Okay, so this is about the scope and potential. Then now coming to the types of renewable energy sources, already we have discussed is wind, solar, hydro, tidal power, geothermal and energy from biomass. So now we'll see what are the applications of wind energy. So it is a very cost effective and reliable needs. And first thing, wind energy, it is used for generation of electricity, wind turbines. Okay. So that electricity can very well be used for pumping of water for our agriculture. So wind turbine electricity generation can be used to raise the living standards of rural people by improving the agricultural productivity. So the productivity of the crop can be increased by means of the wind turbines. That means the electricity can be generated out of wind turbine and that electricity can be used for pumping of water. So after installing these wind turbines, one can raise high value crops throughout the year. So and also we can supply water to the livestock also. And there are many other applications of this wind power. You can go with the domestic water supply. That means pumping of water. It may not be to our fields, but it can be for our domestic water supply. And we can supply water to our livestock. That means cattle, sheep, whatever it is there. Then drainage for salt ponds, for fish farming also, it will be useful. Then electricity generation from wind turbines. So you can generate electricity, and sometimes this wind energy can be converted into mechanical energy also. So this mechanical energy, you can use it for grinding of the grains, for grinding of the legumes, for making powders, okay, or what to say, mills. So where you can use this particular energy. Then applications of solar energy in agriculture, if you were seeing. So solar energy, it can, what to say, it can supply or supplement many energy requirements. As we have already spoken, solar energy can very well be used for a drying purpose. There are many solar dryers are there. So natural, usually in our home, we'll be observing. So the vegetables or whatever it is, for pickles and all, we'll cut and we'll simply spread on the rooftop so that it grabs the solar energy and it dries, the material gets dried. So natural open air dryers are there, direct solar dryers, indirect solar dryers, solar hybrid dryers are there. Hybrid technology, in the sense combination of one or more drying technologies, we call it as hybrid technology. Okay, so solar hybrid dryers are also there. All these are mostly used for drying of the agricultural material. So drying means we remove moisture content from a product to a desirable limit. So that is said to be drying. So I think you might be knowing about polyhouse and greenhouse, polyhouse dryers. So where we'll, so this is the second diagram. So where we will spread the material in trays, and through this polyethylene sheet, the solar light or sunlight will be entering inside. It heats the air that is present inside. Then the air, initially temperature is less, over a period of time the air becomes hot, and that hot air, what it will do, it will remove moisture from the product. Then solar energy can be used for cooking purpose. So this fall into two categories, like solar oven and direct focusing solar concentrators. I have already shown you certain solar concentrators, paraboloid concentrator, cylindrical parabolic concentrator. We will study in depth about all those. So here it is an introductory lecture. So where we will study its applications only. So what is solar energy? What are its applications? That's it. So solar space and water heating systems. So it is mostly used for heating. Then greenhouse heating. So greenhouse, another agricultural application is greenhouse heating. So it has the large thermal mass to collect and store, it stores the solar heat, and insulation to retain this heat for use during night and on cloudy days. So it sometimes it retains also the heat so that you can you can use that during night times and all, or in cloudy days. And as solar energy, PV panels, if we are using that PV panels, what it will do? It will convert the sunlight into electricity. So that is said to be photovoltaic effect. So PV stands for photovoltaic. So that particular PV panels, we must be seeing in our farms and all, where we install certain panels for a pump, okay, for pumping of water. So PV water pumping systems, it is the most cost effective water pumping option, where we don't have existing power source, existing electricity supply. If you don't have, there are certain villages where they may not be having electricity supply to that particular village. So there we can directly install this photovoltaic panels and we can generate electricity. That electricity can be used for pumping of water. That water can be used for our irrigation purposes in our fields. So, and also not only that, we can use that electricity in our household purposes also. So, photovoltaic, you can note down, it is a technology that converts light directly into electricity. And what is the material it is made up of? Solar PV panels, they are made out of highly purified silicon, very important bit. So, photovoltaic materials, they are most commonly, they are made out of highly purified silicon. What they will do? They will convert the sunlight into electricity. So they can power an electrical appliance directly, or they can be stored in a battery. And they may be much cheaper than installing than our general electricity lines. So they may be much cheaper, and you can go with the electrical fencing, lighting, and even water pumping also. So you can take down, these are the various applications of solar energy. So this is a summary about the various applications of solar energy. You can go for heating and cooling of buildings. So that means refrigeration purpose also. So solar energy can be used for refrigeration purpose. I'll be talking in detail about this concept. So what is solar refrigeration, we say. Okay. So here comes that. So this particular topic. So then solar water and air heating systems, and how you can produce salt out of this solar energy. That means by means of evaporation of seawater. So we can use solar energy and we can evaporate the water. So after evaporation, the leftover that it is salt, and the salt production will see solar distillation. Distillation means what? Purification step, we can say, purification of water. So solar drying, solar cookers, water pumping, refrigeration, electricity generation by using the PV panels or photovoltaic cells, solar furnaces, industrial heating process, and solar thermal power generation systems. And the limitations are, so it is a dilute source of energy. It cannot be available throughout the day. And not only that, during some rainy days and in winter season, we won't be getting proper insolation. Insolation means radiation received over a unit area. We call it as insolation. So India being a tropical country, it receives solar insolation in the order of, you can note down this point, very important. It is 1650 to 2100 kilowatt hour per meter square per year. So this much amount of solar radiations can be received and this much amount of energy can be generated per square meter area in a year. So when the solar radiation is 250 to 300 days of an year, the rest they consider it as rainy days or some snowfall and all. So if they calculate effective days in a year, that is 250 to 300. So how much energy can be generated? It is 1650 to 2100 kilowatt hour per meter square per year. And this solar energy can be used directly or indirectly. You can use the sun rays directly, or you can convert that into suitable energy form and we can use that. The third one, it is first one we talked about wind energy and its applications. Then solar energy we have seen, then hydropower. So hydropower electricity for farm appliances like hydroelectricity, it contributes to the storage of drinking water. So mostly dams, if you are seeing, so they store the water. So storage of drinking water and also electrical power can be generated. Power plant reservoirs, they collect the rainwater which can then be used for consumption or for irrigation, and that means irrigation also can happen by means of this particular electricity that gets generated out of the water. So irrigation through hydropower, that is also one of the application. Next, tidal power. As I was telling you, tides are created by means of the gravitational pull. So tidal power, we can use it in the aquaculture. We can go for shrimp farming, farming of that shrimps. Then tidal electricity can be generated, and the energy that is coming out from the tides can be converted into mechanical energy. Mechanical energy means mostly for the operation of machines where you can grind the grains, grinders, we can say. So mills, grain mills. So crushing of grains. So we can get various types of powders and all. So crushing of grains in grain mills, and the movement of turbines. Turbines can be rotated, out of which electricity can be generated, and or also sometimes we can go with the mechanical energy which is used for crushing of the grains. These are some of the uses or advantages. Then biomass energy, as I told, after disintegration we get biogas. So what are its uses? So that biogas, so biogas is a combination of many gases, again you can note down. So the major component of the biogas you can note down, that is methane. How much will be the percentage? It is 55 to 65 percentage. So biogas contains almost 55 to 65 percentage of methane, then 30 to 40 percentage of the carbon dioxide. And then we will have some little traces of hydrogen, nitrogen, hydrogen sulfide. So there will be hardly 1 or 2%. Okay. So this particular gas, it is used mostly for heating the buildings. It is used for drying of the crops. Dairy operations. Dairy operations means heating of the milk, pasteurization and all. So that means this gas is used for heating purpose. So you can heat the water. That water can be converted into steam. That steam can very well be used in the dairy plant and industrial applications also. So generate energy on the farm. So environmental friendly alternative fuels. So that can substitute the gasoline, that means the refined petroleum and all. So it can produce this diesel or can be blended with them to reduce the toxic air emissions. And it produces steam and generates the electricity. So this is also one of the application. So I was talking about diesel production. So biomass can very well be utilized for the production of fuels. So two important fuels, please note down. One is biodiesel, the other one is bioethanol. Biodiesel is produced out of the vegetable oils and animal fats. Bioethanol is produced from the sugar crops like corn, barley, wheat. Okay, so diesel is produced out of a process known as transesterification process. And ethanol, it is mostly obtained by means of fermentation process. Okay, so biodiesel can be produced, bioethanol can be produced. So these two are the fuels. They can use as such, or they can be blended with the fuels, already present fuels. Okay, and this biomass gas, nothing but the biogas. It is used for heating purpose. It is used to produce the steam. It can be used to generate the electricity. The next one is geothermal energy applications in agriculture. So geothermal energy means what? The energy that is present in the deeper layers of the earth crust, that is said to be the geothermal energy. So it has been mostly used for agriculture purpose for heating the greenhouses during the last 25 years. And you can go with the irrigation. Then we can go with the field heating and production of some algae spirulina. So this algae spirulina, it has a lot of nutritional benefits and it has some antioxidant properties also. So it needs hot water for its production. So that heat can be obtained from the geothermal energy. And geothermal aquaculture also you can do. That means we can grow fish. Aquaculture is nothing but growing of fish. So breeding different fishes. So all over the year by using this geothermal energy and drying of agricultural products. Again, the concept of drying has come. So that means wherever the heat is there, that heat can either directly or indirectly be used here. So this heat is further used to make the hot air, that means to generate the hot air. That hot air is used for drying of agricultural products. And sea or brackish water greenhouses. So to combine the greenhouse heating, so you can go with the greenhouse heating of agricultural products. At the same time, you can go with the salt production or desalinization of sea or brackish water using geothermal energy. So geothermal energy is nothing but the heat energy. So that heat is used for what to say, desalinization of seawater. That means removal of salt from the seawater. Then you can go with the heating of soil. We can go for pasteurization of the milk. So that means removal of pathogens from the milk, harmful pathogens. So geothermal hot water can be used for milk production, milk pasteurization, sorry, and drying process, while geothermal steam can be used for evaporation. So what do we get out of evaporation of the milk? So that means it gets more concentrated and we get some sort of milk powders and all out of evaporation process. And UHT, you can note down, it is a ultra high temperature process. So that means that much high temperatures can be extracted by using this geothermal energy. So geothermal energy can be used for drying of produce, then desalinization purpose, for heating of soil, for pasteurization of the milk. So by that we have come to an end of this lecture. about introduction of various renewable energy sources. Let me give a quick summary of this renewable energy sources. So we have seen what is energy, what are its units. We have seen the classification of energy sources, commercial energy source, renewable energy source, its examples. So commercial energy sources, coal, petrol, oil, natural gas. Renewable energy sources are solar energy, wind energy, hydropower, tidal energy, geothermal energy. So then we have seen the advantages and limitations. We have also seen the comparison between the commercial energy sources and renewable energy sources. Then what are the applications? What are the energy sources? First, what is solar energy? What is wind energy? And what are its applications we have seen. So this is about the lecture. And I would like to, maybe further classes, I'll be sharing you the objectives, complete objectives of this particular lecture. But for now, you can quickly go through this particular objectives. So what is renewable energy source, whether it is exhaustible or inexhaustible? Someone said
Inexhaustible.
it is inexhaustible, correct. So renewable energy is mainly obtained by solar, wind, geothermal and all. That is the answer for that. Then tidal energy, it is an example of commercial energy source or renewable energy source?
Renewable energy
Renewable.
source.
So tidal energy is associated with, that means it is associated with sea. Wave energy is associated with oceans. And here you can say the energy that is obtained from the sun is known as solar energy. Units of energy,
Joule, ma'am.
Newton meters or joules. So Newton is the unit of force. M stands for meter, that is the unit of distance. So Newton meter or joule. So example of commercial energy sources, you can say it is coal, petrol, oil, natural gas. So now this point, technology that converts sunlight into electricity. What is that? I have already told you. When we are studying about solar PV panels, yes, photovoltaic. So someone told from KPSC 2024. So it is photovoltaic effect. And solar cells are made of?
Silicons.
Yes, it is semiconductor material. It is made out of pure silicon, germanium, and many other materials are there, but mostly it is made out of silicon. Okay, so this is about lecture number 1. Please go through this, and I'll be sharing the material, PPT, as well as the PDF. PDF will be like, you'll have more, more information, in-depth information in the PDF. But in short, if you want to quickly go through the concepts, you can go through this particular PPT. So that's all for today. And
Ma'am,
yeah, tell me.
ma'am, please suggest some objective books or reference book for this course, ma'am.
Yeah, definitely. I thought to add today, but I forgot. Maybe tomorrow in the next class, I'll be suggesting you some of the reference books. For now, this particular renewable energy source, you can go through this book, that is Non-Conventional Energy Sources by G.D. Rai. You can note down. Tomorrow, I'll be giving you the publisher details and all. So non-conventional or renewable energy sources by G.D. Rai, R-A-I. Okay. And I'll suggest some of the objective books also. Daily in the class, I'll be giving you some objectives. Other than that, one objective paper I'll be discussing as we proceed. So I hope you are able to understand. Is this okay?
Yes, ma'am.
Yes, ma'am, it is.
Yeah. Okay, fine. Then thank you so much. We'll meet most probably tomorrow. Tomorrow I'll be taking, or I have already given the lecture outline to madam, like next class, what it is going to be. Please collect and try to, go through that once. Try to go through the material. Come prepared for the class so that it will be very easy for you to understand. So that is only a small suggestion from my side. And thank you so much.
Thank you, ma'am.
Thank you, ma'am.